Okay, so we want to begin today's class. Okay, last week we started with probability concepts. That's the fundamental of probability, where we looked at some what probability is about. Okay, and we looked at rules on probability, the additive rule, multiplication rule, conditional probability, the Bayes law. Then we proceeded to looking at probability distribution, okay, where we looked at what a random variable is, what the probability distribution is, okay, as well as looking at how to generate the random variable, the probability distribution for a random variable. Then we also looked at the specifically a discrete random variable and the properties of the discrete random variable, okay? And then we solved some few examples, okay, with regards to finding some values of k and then writing out the probability mass function given a particular probability function, okay? And we wrapped up on the properties of the PMF, okay? Like for example, the mean, okay, of a discrete random variable. Today we want to continue from where we left off. Okay, we ended off by finding the mean of a discrete random variable. Last week we said that the variance is also giving us the expectation of s squared minus the expectation of x all squared. And we said that the expectation of x is mu squared, okay? Mu, the expected value, which is the mean value, right? So in the estimation of the variance, okay, what you need to find is the expectation of x squared, which in itself is given as a summation of xi squared times p of xi. Yeah, so in that case, all you need to do is to find the expectation of x squared, okay, and you subtract the square of the mean value, okay, to give you the variance. So as an example, um, we are supposed to, we've been given the probability function as kx, okay, for x 1, 2, 3k into bracket 4 minus x for x 3 and 4. Okay, we have to find the variance. So we want to find the variance, okay, good. So let's see how to solve that. So in estimating the variance, you can create a table like we have here, okay? So you create a table with the formula for the variance, okay? var of x is what? Is summation x, okay, squared times p of x, okay, minus the expectation of x squared, okay, which we calculated last week. So all we need to add is to okay. So all we need to do is to find what or create another row for x squared. This is it. That's the square of x. So 1 square will be 1, 2 square will be 4, 3 square will be 9, 4 square is 16. Then next you multiply x square with P of X, okay? Because you are required to find the product of S squared times P of X. So that will give us 1 times 1 over 6 will be 1 over 6. Then 4 times 2 over 6 will be 8 over 6. 9 times 3 over 6 will be 27 over 6. And then 16 times 0 will be what? Will be 0. Okay, so that gives us S squared times P of X. Okay, then next we have to sum it up, right? So in summing, this is it. This is the summation here, summation. That gives us 36 over 6, which equals to 6. Okay, and then we've already found the mean, mu to be what? 2.33 from last week. Okay, so your variance is equals to 6 minus the mean what? Square. Okay, the square value of the mean. So 6 minus 2.33 square. When you do that estimation, you get 0.571. So that gives us the variance for a discrete random variable. Okay. Now to proceed, good. So that wraps it on the discrete random variable, okay, which we should have ended last week, okay, but due to poor network, we had to omit that session. This week we are looking at probability continuous random variable, or what you refer to as CRVs, okay. Now when we talk about continuous random variable, we are talking about random experiments which occur continuously, okay, so continuous process. So for example, the time to the first phone call is a continuous process, okay. We are not sure if the phone call will even happen, but how do we estimate the probability to the time of the first phone call, okay. Those processes are what? Continuous random variables. Okay, so there are some few things we need to know about continuous random variable. The first thing we need to know is that the probability distribution of a continuous random variable has a special name, which is what? The probability density function. Okay, the probability density function. Good. So the name for the probability distribution of a continuous random variable is the probability density function, which is PDF. Okay, good. And like the PMF, we can also write this as a function, okay, f of x. Okay, good. Now, there are other things we need to know. We say that the probability of a process A, okay, given at a point, okay, is always equals to what? It's always equals to 0. So the probability of the process, the random variable being equal to a particular point, is going to be equal to 0. In other words, the probability of remaining at a point is what? Always equal to what? 0. Okay, good. Then we say that for a continuous random variable, we calculate the PDF, okay. We say that the probability of the process is always greater than or equal to what? 0 over the domain of x. And also the integral of f of x over the domain of x with respect to dx is equal to 1. We know integration is continuous summation, okay. In the case of the discrete random variable, we had what? the summation of what? F of x, okay, over the domain of x, that's from I equals to 1 to n, is equals to what? Is equals to 1. Good. Then if the probability of the process is equal to 0, then it means that what? If it's equals to 0, if fx is not what? In the domain of what? Of x, okay, or in Rx. Very good. Now, for the cumulative distribution, okay, similar to the discrete random variable, let me clear everything. Similar to the discrete random variable where you have summation, okay, from xi to a given point x. Okay, here we are going to integrate. You see the similarities. So summation becomes what? Integration. Okay, from the lower bound, which is negative infinity, okay, to the point what? To the point x. Very good. So in the case of a continuous random variable, the CDF is estimated using what? Integral from lower bound towards the point x. And the expected value of the process, which is the mean, is the integral from negative infinity to positive infinity. That is from the lower bound to the upper bound, okay, of x times f of x dx, okay. So in the case of the discrete random variable, it was summation over the bound of x, f x times what? P of x, okay. So it's the same thing. This time it is integration from the lower value to the upper bound of x, okay. And then we are integrating with respect to what? To the dx, okay. Very good. It's very similar. Good. And if we need a variance, okay, then similar to that for a discrete random variable, we can also write, okay, that the variance is equals to what? The expectation of what? X square. The expectation of x square, okay, minus the mu of x, okay, mu of x squared. Good. So mu of x, like we said, for the discrete case, would have been calculated using this formula. So you don't need to calculate it again, right? This is a formula, okay? So you would not need to recalculate the expected value, okay, when finding the variance, especially when you've already found the mean. So all you need to find will be the expectation of x squared. And the expectation of x squared will also be what? S squared times f of x, meaning you are replacing what? X in this formula here with what? With x squared. Okay. And the integration is from the lower boundary to the upper bound. Okay. That's the lower limit to the upper limit. Very good. So you take note of this formula. Okay. Now proceeding, we want to take a note on which summarizes these equations. Okay, then we come and take some examples on what we've looked at so far. So for the discrete random process, okay, we have discrete values like x, 0, 1, 2, 3, 4. Okay, but in a continuous random variable, we have an infinite sample space, okay, which is over an interval. So from 0 to 1, you have infinite number of what? Values within the interval, okay. Good. And then when you come here for a discrete mass function, that's PMF, the probability is usually written as P of xi, okay, whilst when it comes to probability density function, we prefer using f of x. Okay, good. And then for the same properties where we have p of xi is always greater than 0, here we write f of x is also greater than 0 for x within the domain R of x. Okay, good. Then we have the summation of what? All probabilities equals to 1 from 1 to what? Infinity. Okay, in the case of a continuous random variable, will be the integral of f of x dx is equals to 1. Okay, good, over the domain of x. Then finally we have what? If f of x is equal to 0, meaning the probability is equal to 0, then x is not what? In the domain of x in the first place. Okay, and the CDF2, similar to what we have here, it becomes integral. Okay, from x, from the lower bound to the point x. Okay, with respect to what? With respect to t. Okay, good. Now, if it's within two limits a and b, then the cumulative density function becomes what? The integral of f of x from what? A to what? To b. I'm sure you've taken note of these formulas as well. Okay. Now we have a first question here. Okay, we are told that a live ball of Variance, okay, has a density f of x is equals to k raised to the power k e raised to the power 0.1x. Okay, that's an exponential function. Good. Over the r of x, which is what? 0 to 10. Okay, and so the domain of x is infinite from 0 to what? To 10. Okay, and 0 otherwise. We have to find the value of k. Okay, good. Which reminds us of the sample we looked at in the PMF. Okay, anytime we ask to find the value of k, what we do first is to rewrite the table and then sum the values and equate to 1. Then we look for the value of k, right? So which means that the principle here, or the idea here, is then the summation of all what? F of x over the domain should be equal to what? Should be equal to 1. Okay, if we integrate the function over the domain of x from the lower limit to the upper limit, it should give us 1. Okay, then based on that, we can find the value of k. Okay, so let's proceed and work that out. Okay, so in calculating this, we are going to get make f of x. Okay, let me rewrite this. Good. So what we are saying, per what we just said, we are saying that, just a minute, let me clear the screen. Okay. Since we are not in slideshow mode. Okay. So what we are saying is, if we're to integrate, okay, over Rx, the function, okay, with respect to x, with respect to x, that should give us what? 1. Okay, and the domain was clearly stated from 0 to 10, okay, which implies that we are going to integrate the given function, which was what? K e raised to the power negative 0.1 x from the limits. Let me change the color here. So from the lower limit, which is 0 to what? To 10. Okay. And then we integrate with respect to what? Dx, which will be equal to what? 1. Okay. Good. Now, because k is a constant, okay, then we can pull it out of the integration sign. Okay. So then we have k, okay, integral of e of x, e raised to the power negative 0.1 x from 0 to what? To 10. Okay, good. And then once we have that, we'll have to integrate. We have to integrate e raised to the power negative 0.1. Okay, negative 0.1 with respect to x. Okay, and then integrating e raised to the power negative 0.1. Okay. Negative 0.1, we're going to get what? K. Okay, and then when we integrate the function, we get e raised to the power what? Negative 0.1 x, okay, over negative 0.1, okay. Then we evaluate over the limit 0 to what? To 10, and then this should be equal to 1. Okay, good. So once we've obtained that, we substitute the limits, okay, into the function. We evaluate by substituting what? The limit into the function. So this is going to give us, we have k outside the bracket. This will give us e raised to the power negative 0.1. Then your x is 10. So this becomes 10 minus e raised to the power negative 0.1. Your x is here, is at this point is what? Is 0. Okay, very good. So once we evaluate that, this will be negative 0.1 times 10, okay, which will give us negative 1. And then there is negative 0.1 times 0, which is equals to 0, okay? Good, and we know e raised to the power 0 will be equal to 1. Okay, yeah, and then you also have to evaluate e raised to the power negative 0.1, okay, over 0.1. So you calculate this term here. Okay, so e raised to the power negative 1 over 0.1 should give us what? Negative 3.678. And then e raised to the power 0, that's 1 over negative 0.1 should give us negative 10. Okay. So I'm going to give you time to do the calculation and be sure you are getting it on your calculators.
Yes, sir.
Yeah, did you get it?
Yeah, that's what I got, sir.
Okay, very good, very good.
Yeah, that's the same thing.
Okay, that's good. So let's continue. I wanted you to be sure that it's okay. Okay, so once we have that value, then you make k the subject, okay, by dividing both sides by 6.32, which will give us k to be 0.5 0.158, which means that the probability distribution of the process, okay, is 0. We replace the k in the original function, so it will be 0.8, okay, e raised to the power what? Negative 0.1x, okay, defined over the domain what? 0 is less than or equal to x, is less than or equal to what? Is less than or equal to 10. Okay, very good. So that is how we work out the summation, okay, of the probability density what function. Okay, so in this example, you do integration. So which means you have to go back and then go and learn your rules in integration, okay, especially integration by parts, to help you to find the mean and the variance of a continuous random variable. Okay, now moving on, we have a follow-up example, which is to find the expectation of x, okay, and then to also determine what the CDF, that is for x greater than or equals to 4. Okay, now let's see how we're going to attempt this question. So in finding the expectation of x, okay, which I'm going to give to you as an assignment anyway. The expectation of x, we said, is going to be the integral, okay, from negative infinity, that's the lower limit, to the upper limit, okay, of x times what? F of x with respect to what? With respect to dx. Good. That is the expectation of the process. So which means that in evaluating that, your lower limit is 0, your upper limit is what? Is 10. And then we have x times the function. We calculated the function, the k value to be 158 e raised to the power of negative 0.1x, okay, dx. Good. So which means that you can bring the constant out, which is 0.158, okay, and then we have e raised to the power negative, we have x here times e raised to the power negative 0.1 x dx, okay, from 0 to what? To 10. Okay, good. Now the integration here will be done using what? Integration by parts. Why? Because we have a linear function x, and then we have an exponential function e raised to the power what? Negative 0.1 what? X. Okay, so you may want one of the functions to be v, and the other function to be what? Du. Okay, for your integration by what? By parts. Okay, so that will be your assignment for today. You have to go and find the expectation of the process. Good. And then once you are done with the expectation, okay, I'm going to do the CDF for P of x greater than or equal to what? 4. Okay. Now, to obtain that 2 is very simple. All you need to do here is you are supposed to integrate. We're told x is greater than or equal to what? Or equal to 4. So it means that 4 will be your lower limit, and the upper limit of x remains what? 10. Okay, and the function is 0.158 e raised to the power what? Negative 0.1. This is 0.1x. Okay. 0.1x. Okay. So if we are integrating, this is going to be 0.158. Okay. And then integral of what? E raised to the power 0.1 x 0.1x with respect to dx. Okay, from 4 to what? To 10, which will also give us e raised to the power negative 0.1, negative 0.1x over what? Over negative 0.1, okay, minus e raised to the power what? E raised to the power negative 0.1 x, okay. Oh, sorry. Let's, because we've not substituted the limit yet. We were skipping a point, one step. So this will be, first you have to evaluate at the limit 10 and 4, okay? Then we come to the substitution step. So this is 0.158. Good. Next we go to the evaluation step. That should give us 0.158, okay, into bracket e raised to the power what? Negative 0.1 times what? Times 10, okay, over negative 0.1, okay, minus what? E raised to the power negative 0.1, okay, times, this time times 4, okay, times 4 over negative 0.1. Good. So once we do the calculation, this is 10 here, okay. So once you calculate, that should give us 0.158, okay. And then what do we get in the brackets? Can you do the calculation for me? Yeah, what are we getting in the bracket? Joseph, what are we getting? Yeah, the bracket value, what are we getting? This quantity minus this quantity. What do you get? Your line was breaking, so I couldn't hear you. Okay. Can somebody send it as a chat to me? Just send it as a chat.